Math Dude here, getting ready to look at parabolas. The parabola is an important shape in mathematics and in the physical world. When drawn on a graph, it looks a bit like the letter U. It's the basis for lenses found in telescopes, the microphones those guys on the sidelines of football games carry so you can hear all the action, and it's used in determining the speed and trajectory of flying objects. See, that guy needed to know more about parabolas. A parabola is the graph of a quadratic function, and a quadratic function is one that has a square as its highest exponent. The standard form of a quadratic function is y equals ax squared plus bx plus c, when a doesn't equal 0. So let's take that quadratic function and put some values in for a, b, and c. We'll replace the a with 2, the b with 4, and the c with -3. And we can simplify it a little by changing the plus -3 to -3. As with any equation, we can substitute values for x and solve for y, then put those points on a graph. We'll take the numbers 2, 1, 0, -1, and -2, and substitute them into the equation. When x equals 2, 2 squared is 4, 2 times 4 is 8, 4 times 2 is 8, 8 plus 8 is 16, and 16 minus 3 is 13. So, y equals 13. We can perform the same operations when x equals 1. So y equals 3, and so forth. Then we'll take the points and put them on the graph. If we connect the points that we have so far, the graph appears to reach a point where it completely changes direction. Also, notice that 2 points have the same y value, 0, -3, and -2, -3. Coincidence? Let's find out. We'll take the next 2 lower values for x, -3 and -4, and substitute them into the equation. And graph the points. -3, 3 and -4, 13 do indeed have the same y values as 2 other points. When we connect these points with the rest of the graph, we have a parabola. Let's take a look at some of the points on the parabola. Notice that the parabola has a turning point, a point where the graph changes direction. This point is called the vertex. As you look at the points, you may notice that the pairs seem to go together. In fact, if we consider a vertical line passing through the vertex, you notice that each point to the left of the vertical line has a corresponding point to the right. We say that this graph has symmetry, meaning that each side of the graph is a mirror image of the other. And that vertical line is called the axis of symmetry. If we folded the graph on that axis of symmetry, all the points on the left would cover all the points on the right. We can use the idea of symmetry to help us graph the parabola. The equation for the axis of symmetry can actually be found using the coefficients of the quadratic equation and this formula. If the quadratic equation is in standard form, y equals ax squared plus bx plus c, then the axis of symmetry can be expressed by the equation x equals -b divided by 2a, where b is the coefficient of the x or linear term, and a is the leading coefficient, the coefficient of the x squared or quadratic term. So, in our original example, y equals 2x squared plus 4x minus 3, b is 4, and a is 2. When those values are substituted into the equation and simplified, the axis of symmetry is x equals -1. On a graph, that's the vertical line passing through -1 on the x-axis. So now we know that our parabola is going to wrap around that axis of symmetry. Next, we need to know where the vertex will be. We know the vertex has to be on that axis, and that every point on that axis has an x value of -1. So we'll go back to the original equation and substitute -1 for x. Watch out for those negative signs as we solve for y. Remember, -1 squared is +1. And we find that when x equals -1, y equals -5. Therefore, our vertex is the point -1, -5. We can indicate that on the grid. We mark the vertex as -1, -5. Now we have a starting point for our graph. But now we need more points to complete the parabola. One point that's convenient to find is the y-intercept, the point where the parabola will cross the y-axis. Remember, all the points on the y-axis have an x value of 0. If we take our equation and set x equal to 0 and solve for y, we get y equals -3, which, by the way, was the c term, the constant in our quadratic equation, and that will always be the y-intercept. So our y-intercept is -3. Now we have 2 points on our graph. Our third point will be very easy to find if we use the idea of symmetry. Now remember, for each point on the right of the axis, there's a corresponding point on the left. Therefore, since the y-intercept is 1 unit to the right of the axis of symmetry, there must be a point 1 unit to the left. That's the point -2, -3. Now we have 3 points. A couple more would be nice.